Year 10 Standard Form Lesson 2. So we're going to have a look this lesson at how we can simplify calculations involving numbers written in standard form. We're going to start off by looking at multiplication. As always, we will illustrate this with a series of examples to make sure we really understand what we can do with these sorts of calculations. So I'm going to start off with the calculation 2 times 10 to the 3, so that number in standard form, multiplied by 4 times 10 to the power 5. The brackets here don't really serve any mathematical purpose. They're just there to show you the difference between the two numbers and to make the different numbers clear for you. So let's start by multiplying these parts here, because remember, multiplication is commutative, which means we can multiply these four terms together in any order. So 2 multiplied by 4 gives us a value of 8. And then we need to work out the overall power of 10 involved, because we have 10 to the 3 multiplied by 10 to the 5. And of course, what happens when we multiply terms together? What do we do with the indices? We add them together. So the answer is 8 times 10 to the power of 8. Let's try another example of this. So my second example, 3 multiplied by 10 to the power 5 multiplied by 2 multiplied by 10 to the negative 7. So again, we are going to multiply these two numbers together, but we're going to multiply the parts in a slightly different order, which again is allowed because the only operation happening here is multiplication. 3 multiplied by 2, of course, gives me 6. So I have 6 times 10 to the power. Now, 10 to the 5 multiplied by 10 to the negative 7, we need to add those indices together. What is 5 add negative 7? It is negative 2. Let's try another example. 4 times 10 to the negative 3 multiplied by 1.5 times 10 to the negative 8. Well, 4 multiplied by 1.5 gives me 6. You might like to write 6.0, it doesn't matter. And we want that times 10 to a power. So we have 10 to the negative 3 multiplied by 10 to the negative 8. So again, remember, you're multiplying, the bases are the same, they're both 10. So you need to add your indices. Negative 3 add negative 8 is negative 11. What about one last example? 8 times 10 to the negative 3 multiplied by 1 times 10 to the 9. So, again, let's start with these parts. 8 times 1 is simply 8. And then we have 10 to the negative 3 multiplied by 10 to the 9. Add your indices, and this will give you your overall index here for 10. Negative 3 add 9 is equal to 6. So the answer is 8 times 10 to the power of 6. Now, we're going to look at two further examples where we have to be a little bit more careful. So example number 5, here comes the calculation. 2 times 10 to the 7 multiplied by 8 times 10 to the power 5. Now, the first stage of this is never that difficult. 2 multiplied by 8 gives you the 16 at the start of this. And then that's times 10 to the power, well, 10 to the 7 times 10 to the 5. We must add our indices, so 10 to the 12. Now, have some of you spotted the problem with this answer? It's not completely correct. And the problem is, this part here is not between 1 and 10. So this currently is not in standard form. To be in standard form, the first part of that number here must be between 1 and 10 to be in proper standard form. So we need to convert it. How do we do that? Well, instead of 16, I turn that into 1.6. So how have I done that? Well, I have divided 16 by 10. Now to do that, I need to balance the number, so the other part of the number needs to multiply by 10. So my final answer will be 1.6 times 10 to the power of 13. If 1/2 of the number becomes 10 times smaller, 16 converted into 1.6, the other part of the number needs to balance that by becoming 10 times bigger, so 12 becomes 13 in the index. Let's try that with another example. So example number 6, we'll do this over here. I have 3 times 10 to the power 4 multiplied by 6 times 10 to the power of -9. So first step, as I said, always easy. 3 multiplied by 6 gives us the 18 at the start of this already. We might be spotting the problem. Times 10 to the power. So 4 add power 9 gives us a power of -5. Now again, here's our issue. The 18 is bigger than 10. So we need to convert that to a number that is between 1 and 10, but not 10. So of course, what number is it going to become? It's going to become the number 1.8. Now, how have I turned it into 1.8? Of course, I have to divide by 10, which means over here in the other part of the number, I need to multiply by 10. So what happens if we multiply 10 to the -5 by 10? Well, it's going to become 10 to the -4. Think about it. You're doing 10 to the -5 multiplied by 10 to the 1. It's going to become 10 to the -4. Now, something that might help when you're thinking about this is what happens to powers of 10 as you multiply by 10 or as you divide by 10. Now, here is a list of powers of 10. So we have 10 to the 0 in the centre, 10 to the 1 up above that, 10 squared, etc. up above. And then we have the negative powers because these represent smaller numbers below. As you multiply by 10, or multiply by powers of 10, the powers will become more positive. As you divide by 10 or divide by multiples of 10, the powers will become more negative or smaller. So that's something that could be quite useful when you're having to convert a number that isn't in standard form back into standard form. So now it's your turn. In each of these questions, complete the multiplication, and then in each case, work out whether you then need to do a little bit more work to convert the result into true standard form. You must not use a calculator during any of these questions. The answers will come up in a few seconds, so make sure you pause the video. So here are the answers to the questions. Make sure you check them through. Hopefully you spotted that in E, F, G, H and I, all of the first answers that you got needed to then be converted into true standard form. Now, I've included a few examples on what happens when we square involving numbers which are written in standard form, so you can see how this works. Remember that squaring is a form of multiplication. So, for instance, let's have a look at a few examples to illustrate this. I'm going to work out what 2 times 10 to the 5 is if I square it. Now, what does squaring mean? It means 2 times 10 to the 5 multiplied by 2 times 10 to the power of 5. So all I then need to do is apply the rules that I've just looked at for multiplication. 2 multiplied by 2, of course, gives me 4 as a starting point. And then 10 to the power 5 multiplied by 10 to the power 5 gives me 10 to the power of 10. Job done. Now, what happens if we end up with one of the trickier calculations, so example number 2, what happens if we end up with, let's say, 5 times 10 to the -3 all squared? Again, I advise writing it out as a multiplication, like this, and then let's deal with 5 multiplied by 5, which gives us 25. And then let's deal with the powers of 10. So 10 to the negative 3 multiplied by 10 to the negative 3, we add our indices together, so that gives me 10 to the negative 6. But as with some of the previous examples, hopefully you've spotted that the result is not in standard form because the first part, 25, is not between 1 and 10, excluding 10. So we need to rewrite this as 2.5. Well, how did I do that? I divided by 10 in this part of the calculation, so I must multiply by 10 to balance. So 10 to the negative 6, when you multiply by 10, remember the powers are going to become more positive, moving up the powers on that list, so that's going to become negative 5. So we have 2.5 times 10 to the power negative 5. So now it's over to you. Have a go at these 8 questions, write out your working carefully, and remember you may need to convert some of these answers into true standard form. The answers will come up in a second, so make sure you pause the video first. So here are the answers, and hopefully you spotted that parts C, D, E and F all required a second stage of working. So we're now going to have a look at a series of questions that will involve division. So as ever, here come some examples. So number 1, we've got 4 times 10 to the 9 divided by 2 times 10 to the power 3. So, as last time, but we need to do division this time instead, 4 divided by 2 gives me a 2, times 10 to the power of, and we are working out 10 to the 9 divided by 10 to the 3. What happens when we divide and we have got terms that involve indices? We subtract the indices when the base is the same. So 10 to the 9 divided by 10 to the 3 is 10 to the power of 6. 9 take away 3 is 6. So as simple as that. Let's try a few more examples. So 5 times 10 to the power of negative 7 divided by 2 times 10 to the power of 6. So 5 divided by 2, first of all, is of course 2.5, giving us the first part of our number. Then we want 10 to the negative 7 divided by 10 to the 6, subtract the indices, so you have to work out negative 7, take away 6, which is negative 13. Question 3. 6 times 10 to the power 3 divided by 3 times 10 to the power 8. So we have 6 divided by 3, which is 2. Times 10 to the power of, so we have 10 cubed divided by 10 to the power 8, subtract indices, it's 10 to the negative 5. And one final example, 4.5 times 10 to the negative 5 divided by 2 times 10 to the negative 9. So 4.5 divided by 2 is 2.25. And then we have this times 10 to a power 10 to the negative 5 divided by 10 to the negative 9. Negative 5 minus minus 9. Now do write the calculation out if it helps you. Negative 5 minus minus 9 is of course the same as negative 5 add 9, which gives you an answer of 4. So far, so simple. What about the trickier questions? So as we did last time, we're going to look at 2 examples where we have to take things to the next stage. So let's start with example number 5. I've got 4 times 10 to the power 6 divided by 8 times 10 to the power of 2. So first job is of course to work out 4 divided by 8, which we should know is 0.5. And then this is times 10 to a power. So we've got 10 to the 6 divided by 10 to the 2, which gives me 10 to the power of 4. Now, hopefully you've spotted that the number we've got as an answer is not in standard form as it stands. Why is it not in standard form? Well, the first part should be between 1 and 10. But remember, not 10. So that means we need to do a little bit of that conversion we looked at. So I need to convert 0.5 into a number between 1 and 10. I'm going to obviously convert it into the number 5, or 5.0, by multiplying by 10, which means here I need to divide by 10 in order to balance out the calculation. If one part of the calculation has been multiplied by 10, the other part's going to need to be divided by 10 to keep the number the same. So 10 to the 4 divided by 10 gives me 10 cubed. Go back and look at that list of powers of 10. What happens when you multiply it by powers of 10? The powers become more positive. What happens when you divide by 10? The powers become less positive or smaller. Let's try this out on another example. So number 6, we have 3.2 times 10 to the negative 4 divided by 8 times 10 to the power of 5. So starting point here, 3.2 divided by 8 is of course 0.4. And we have 0.4 times 10 to a power. Well, 10 to the negative 4 divided by 10 to the power of 5. Our initial calculation is minus 4 minus 5 for the power, which of course is negative 9. So 0.4 times 10 to the negative 9. And again, we have the same problem. The first part of this is not between 1 and 10. Well, how do you convert 0.4 into a number between 1 and 10? You multiply it by 10. So it becomes 4, which means we need to divide this part of the number by 10 to balance it out. So what happens? You've got 10 to the negative 9, you divide by 10, it's going to become 10 to the negative 10. And again, I refer you back to that list of powers we wrote down of 10. What happens when we multiply? What happens when we divide? Look at how the powers change. So here's your turn. I want you to work out each of these without using a calculator. Again, in some questions, you will have to take your answer and then rewrite it so it is in true standard form. That won't be necessary for all of the questions. Can you work out which ones you then need to convert again? So the answers will pop up in a few seconds. Make sure you pause the video. First of all, try all the questions, then mark your work. So here are your answers. And again, hopefully you will have spotted that in E, F, H and I, your initial answer then needs to be rewritten in true standard form, so there's a bit more work in each part of the question there. So lastly, we're going to have a look at adding and subtracting numbers written in standard form. Now we'll start off with a very easy example to begin with, and you'll see just how easy this is. I'm going to write down the first question. So we're going to work out 3 times 10 to the power of 4 plus 5 multiplied by 10 to the power of 4. Now, how can I do this? Well, there are multiple ways in which I could have a think about this. I could write these out in ordinary form. So 3 times 10 to the 4 is 3, and 4 zeros, 30,000. 5 times 10 to the 4 is 5, and 4 zeros, 50,000. If I add together 30,000 and 50,000, I of course get an answer of 80,000. But if I want to write that in standard form, well, of course I can do that quite easily. It's 8 times 10 to the power 4. 1, 2, 3, 4. Think about your previous lesson. Now, some of you will then have noticed that, well, 3 plus 5 is 8, and then we just have the same overall power of 10 to the 4 afterwards. So would we be allowed to do that? Well, we can do that if you have the same power of 10 only. So it would have worked in this example to have just added 3 and 5 and then made sure the answer was written out as times 10 to the power 4. Now, why does this work? Well, if you think of 10 to the power of 4 as x, effectively, all you're doing is 3x plus 5x. Now, if you added 3x and 5x together, that would give you 8x. x. But remember, the x actually represents your times 10 to the power of 4. So there's 3x, which is 3 times 10 to the power of 4, plus 5x, which is 5 times 10 to the power of 4. And of course, that will then equal 8x, which is 8 times 10 to the power of 4. So in this scenario, I'm thinking of x as 10 to the power of 4. So this only works if you have the same power of 10. Now, let's look at a harder example. 2 times 10 to the 3 plus 3 times 10 to the power of 4. So you can see that the powers do not match. So we can't go about this in the simple way we looked at previously. But what if we make the powers match? So at this point, we're going to actually do this in two different ways. So I'm going to go split screen here, and then we're going to look at the two possible methods. So I'll call this method 1. What we're going to do is we're going to write both numbers so they have a power of 3. So I'm just going to write out my calculation again. 2 times 10 to the power of 3 plus 3 times 10 to the power of 4. So what I would like to do is now write the first number just as it is again, 2 times 10 to the power 3, but the second number, we're going to rewrite 10 to the 4 as 10 to the power of 3. Now, how does that happen? Well, that means we've divided this part of the number by 10, which means we need to multiply this part of the number by 10 to give us 30. Now, at this point, some of you might be saying, well, why are we allowed to do that? 30 times 10 to the 3 is not in standard form. And that's because 30, of course, is above 10. But it's okay, because we haven't finished yet. This is just a midpoint of the calculation, and at the end of the calculation, when we present our final answer, we can deal with this problem. So it's absolutely fine if in the middle of a calculation you end up with a number that's not in standard form, as long as you convert it at the end. So we now have, in both numbers, the same power, 10 to the power 3, so we can add together these parts of the number to give us 32 multiplied by 10 to the power of 3. Now, this is the point at which we want to stop and remember that this is not in standard form. So I would like to rewrite 32 as 3.2. How am I doing that? I am dividing that number here by 10, which means let's multiply this number by 10. So I get 3.2 times 10 to the power of 4. And here is my final answer. Let's look at one last final example. So we're going to look at the calculation 5 times 10 to the power of 4 subtract 3 times 10 to the power 2. So again, you may wish to have a look at the two separate ways in which I'm going to do this calculation. Method 1, over here. So in the first method, I am going to leave the first number as 5 times 10 to the power 4, but the second number, I am going to convert it. So instead of times 10 to the power 2, it's times 10 to the power 4 as well. So how do I do that? Well, I need to multiply by not just 10, but by 100. So I'm multiplying by 100, or 10 squared, which means over here I need to divide by 100, or divide by 10 squared. So that gives me 0.03 times 10 to the power 4 in that part. So this now means I have to work out 5, subtract 0.03, which will give me, and again you've got to try and do this without a calculator, 4.97, and then for the second part, that is times 10 to the power of 4. So nice and quick to get to our answer, which is in standard form, so we don't have to worry about converting it. What about if we, this time, leave the second number as 3 times 10 squared, but we convert the first one so it is also times 10 squared. So what's happened here? Well, to do that, I've got to divide by 100 or divide by 10 squared, which means in this part here, I've got to multiply by 100 or multiply by 10 squared, which gives me 500 times 10 to the power 2. Take away 3 times 10 to the power 2. Well, let's do the subtraction. 500 take away 3 is perhaps easier to work out than with the decimal values because that's just 497. Now for the second part of this is going to be times 10 to the power of 2. But here's where we look at this and we say this is not in standard form. So what do I do to convert to standard form? Well, rather than 497, we need to make it 4.97. Now, that means we have divided this part by 100, which means this part here needs to multiply by 100, which gives us 4.97 times 10 to the power of 4. So again, have a look and see we have the same answer. So now it's your turn. Here are 9 questions for you to practice. Don't forget to press pause. The answers will come up in a minute. So here are your final answers. Make sure you check your calculations very carefully. Please don't just copy in the correct answer. If you've got a question wrong, go back, try and fix it, try and work out where and why you went wrong, and please ask and get in touch if you're not sure.